Imagine stepping onto the mysterious surface of the moon, a place where the silence of space is as overwhelming as the breathtaking view of Earth on the horizon. However, despite the beauty and fascination the moon holds for us, it hides extremely hostile conditions that could turn a simple visit without proper equipment into a death sentence. Without breathable atmosphere, with virtually no atmospheric pressure, and threats like intense radiation and extreme temperatures, the moon is an environment where human survival depends entirely on advanced technology. But what would really happen if you spent just 1 minute on the moon without a spacesuit? Could we somehow survive this extreme experience? Or would it be as fatal as scientists predict? Let's dive into this intriguing scenario and explore the science behind the dangers of being unprotected on the moon. Decompression is one of the most immediate and dangerous effects that occur when a human is exposed to the vacuum of space without the proper protection of a spacesuit. On the surface of the moon, where atmospheric pressure is practically non-existent, bodily fluids such as saliva, tears, and the liquid present in tissues begin to vaporize. This happens because fluids tend to boil at lower temperatures when external pressure is reduced. For instance, while water boils at 100 degrees Celsius at sea level on Earth, it can boil at temperatures as low as human body temperature, about 37 degrees Celsius, in the lunar vacuum. This phenomenon is known as low-pressure boiling and results from the decrease in external pressure that normally helps keep liquids in a liquid state. When bodily fluids start to vaporize, the result is a painful swelling of exposed tissues. This swelling is known as ebulism. Rather than a uniform swelling like a balloon inflating, ebulism can cause irregular expansion of tissues, leading to damage to cells and capillaries. Imagine a sponge being quickly stretched in all directions. Similarly, the body's tissues begin to expand uncontrollably. This not only distorts the shape of tissues, but can also disrupt normal cellular functions and damage internal organs, resulting in multiple organ failure if exposure is prolonged. Decompression also affects blood circulation and respiration. With the vaporization of fluids, pressure within blood vessels can drop, leading to circulatory collapse. Additionally, gas exchange in the lungs becomes ineffective, as oxygen cannot be adequately absorbed and carbon dioxide cannot be expelled, leading to asphyxiation. This process is analogous to what happens when a diver rapidly surfaces, a condition known as decompression sickness, or the bends. Without a spacesuit supplying oxygen, anyone on the lunar surface would face immediate and severe consequences. Chief among them is hypoxia, a condition that occurs when the body doesn't receive enough oxygen. In the moon's vacuum, where there is no oxygen, unconsciousness can occur in as little as 15 seconds due to the rapid depletion of oxygen in the blood and brain tissues. When the brain is deprived of oxygen, even for a short period, cells begin to die, a process known as cerebral anoxia. This damage can be irreversible and result in permanent harm, including loss of motor, cognitive, and memory functions, depending on the duration and severity of oxygen deprivation. Besides brain damage, the lack of oxygen also affects other vital organs. The heart, for instance, would suffer from a lack of oxygen needed to pump blood effectively, leading to severe cardiac complications such as arrhythmias or cardiac arrest. Without adequate oxygenation, other body systems would begin to fail rapidly, a state known as multiple organ failure. On the moon, the absence of a substantial atmosphere means there is no air to breathe and no thermal barrier to protect against temperature fluctuations. This hostile environment can dramatically vary between thermal extremes, depending on direct exposure to the sun or being in the shade. Temperatures on the moon can swing between approximately 173 degrees Celsius during the lunar night and up to 127 degrees Celsius under direct sunlight. This variation is far more extreme than anything experienced on Earth. To put it in perspective, the lowest temperature recorded in Antarctica was about 89 degrees Celsius, while the highest in Earth's desert environments can reach about 56 degrees Celsius. These extremes are mitigated on Earth by the presence of an atmosphere that helps regulate thermal variations, something that does not exist on the moon. Exposure to these extreme temperatures without proper protection can lead to immediate thermal damage to the human body. In high lunar temperatures, body tissues can suffer severe burns, similar to third-degree burns caused by a fire. Conversely, exposure to extremely low temperatures can result in the instant freezing of exposed tissues, damaging cells, and potentially leading to necrosis, where the dead tissue must be surgically removed. On Earth, the atmosphere and magnetic field act as protective shields, absorbing and deflecting a significant portion of this radiation, which includes ultraviolet, UV rays, X-rays, and high-energy particles. Without this natural protection on the Moon, radiation directly hits the surface, where it can penetrate living tissues and cause severe cellular damage, particularly to DNA. This type of damage is a primary cause of cellular mutations that can lead to cancer. Solar radiation, which is the radiation emitted by the sun, includes not only visible light, but also UV rays and X-rays. These latter, in particular, have enough energy to ionize atoms and molecules, which can result in the breaking of DNA strands and the alteration of other essential cellular structures. For example, brief but intense exposure to UV radiation can result in severe sunburn on Earth. On the Moon, the lack of atmospheric filtering would exponentially increase these effects, causing much faster and more severe damage. In addition to solar radiation, galactic cosmic radiation, GCR, also presents a serious risk on the Moon. These high-energy particles come from outside the solar system and, in some cases, even from distant galaxies. Their energy is much greater than typical solar radiation, making them capable of penetrating even deeper into tissues and causing a broader spectrum of biological damage. On Earth, most of these particles are deflected by the magnetic field or interrupted by the atmosphere, but on the Moon, they would strike the surface almost unimpeded. Throughout this video, we've explored the extremely dangerous conditions of the lunar surface, highlighting why spending just 1 minute on the Moon without a spacesuit would be fatal. We've discussed how the lack of breathable atmosphere, exposure to intense radiation, and extreme temperature variations can cause irreparable harm to the human body in a matter of seconds. Concluding, it's obvious that without the advanced protection of spacesuits, human survival on the Moon is impossible. Answering our initial question, no, we wouldn't survive this extreme experience. But it's fascinating to imagine the impossible possibilities. If you found it fascinating to learn more about the Moon's hostile conditions and the science behind the spacesuits that make lunar exploration possible, don't forget to like this video and subscribe to the channel for more content like this. Enjoy exploring possibilities and interesting theories? Check out our video where we talk about the animals you should be glad are extinct. Your curiosity about space and science can lead us to explore more mysteries of the universe and the world together in future videos.